Sorry about that. Okay, we're going to go over the magnets section from lesson 6, which is the whole lesson is electricity, but we're just going to look at the magnets section of that today. So what makes a magnet? Well, in most materials, the electrons all the electrons all orbit a nucleus, but they spin in random directions while they do. In a magnet, the electrons all spin in the same direction. This happens naturally in a natural magnet, and in an artificial magnet, this is made to happen. Electrons with the same spin are aligned in groups called domains. If a piece of iron comes near a magnet, the domains line up and work together, giving the iron magnetic properties. We say it has been magnetized. A temporary magnet loses its magnetic properties quickly as the domains go back to normal. A permanent magnet's domains stay aligned for a long time. Magnets always have two sides, and those sides are not like each other. We say they are unlike. One side is called the North Pole, and the other side is called the South Pole. Magnets will always have two poles. If you break a magnet in half, each half will still have a North and South Pole. North poles push away other North poles, South poles push away other South poles, but North and South poles attract each other. The poles are places where magnetic field's attraction is the strongest. Magnets have an area around them that they can affect. This area is called a magnetic field. Lines of a magnetic field start at the North Pole and curve around to the South Pole. These are drawn as lines of magnetic force, and those lines can actually be seen in real life if you scatter tiny pieces of iron around a magnet. Each of the tiny pieces will follow those lines of force. Where the lines are denser, the field is stronger, and where the lines are farther apart, the field is weaker. Because the core of the Earth contains iron, the Earth acts as a giant magnet. It is covered by a huge magnetic field. The South Pole of the Earth magnet is actually near the North Pole geographically, and the North Pole of the magnet is actually near the geographic South Pole. A compass always points north because it is attracted to the magnetic South Pole, which is on the north side of the Earth. If a piece of iron or one of its alloys is put into a magnetic field, that piece of metal becomes magnetic. When it is removed, it loses its magnetism. Magnetism that only comes from being placed in a magnetic field is called induced magnetism. Different alloys can be induced more or less easily. We call the measure of how easy it is to induce the magnetism permeability. The table at the end of the reading assignment for this section gives values for different metals. You can see that copper has a low permeability, so it is very hard to induce magnetism in copper. The alloys like permalloy and superalloy are easily induced. They have high permeability. And that brings us to the end of this section, but if you have any questions, we encourage you to contact your instructor using one of these methods.